All right, students, so welcome to another amazing lesson. And in today's video, we're going to be solving some tutorial sheet questions. Of course, this tutorial sheet is very big, but I've decided to just focus on important things which I've observed that they always bring on the exam. Okay, and these things are the trigonometric equations and the trigonometric identities. They'll tell you to solve the equation. They'll tell you to prove an identity. So I'm going to start from, this is tutorial sheet 13. I'm going to start from question 11. So in this video, I'm going to solve from question 11 up to question 13. Okay, because these are the things which they like bringing on the exam on trig. Okay, so we'll start with question 11, verify each of the following identities. Question 12, solve each of the following equations. Question 13. And also, in the tutorial sheet in tutorial sheet 12, I've picked these important questions as well. In the tutorial sheet for trig as well. Okay, so now there is more about trig than what is in the tutorial sheet. So these other questions involving graphing, these things are there on the app. Okay, so whatever you're going to learn in this video, it is just 20 to 30% of trigonometry. Okay, but trust me, these questions always come. They always ask about proving an identity and solving a trigonometric equation. So by just watching this video, by just finishing this video, it is guaranteed that you've secured more than I think 2 to 3 questions on trig that they are going to get from what is just going to be solved. You've already secured about 15 marks, if at all they want to go beyond 3, but they always ask more than 2-3. So from just the concept which you are going to solve, proving an identity and solving a trigonometric equation. Okay, so congratulations for coming to this video. You have just earned yourself some free 10 marks plus, because maybe 10 to 15 marks, because I think each question, I don't know if it will have 4 or maybe 5, I don't know, but yeah. So now there's more about trig. There is hyperbolic trig, there is further complex numbers, there is the Moeber theorem, and these things I didn't see them in the tutorial sheet, but these things are there on our application. We have an app called A+ Academy app, where you find these other remaining 70% of trig. This video is only covering 20 to 30%, somewhere there, but the remaining percentage, things have been taught on the A+ Academy app, and they have been simplified. Videos for trig have been taught in a way that they are just focused on important things. Trust me, trigonometry, there are many irrelevant things, and some of you are even like solving irrelevant questions which they have never brought before, which they might not even ask. But us as A+ Academy, we just focus on important things. Like the way in this video, I'm going to focus on things I've observed that, or questions I've observed that they always ask. Of course, even graphing, but graphing of trigonometric functions, these things also come. Okay, but these things are there on the app. Because to avoid making this video long, I decided to just focus on trigonometric equations and trigonometric identity proving. Okay, so I hope that you enjoy, and before you even go anywhere, before you even proceed watching this, make sure that you like this video and subscribe to the YouTube channel. I repeat, subscribe. I know whenever I say subscribe, you'll be like, why should I subscribe? You know, some of you think that YouTube pay us. YouTube does not pay in Africa, in Zambia. Let me just say in Zambia, YouTube does not pay. Even if you get 1 million views, you won't be given even a one ngwe. So it's not like I'm saying you are paying me by subscribing. You are supporting the YouTube channel so that I can be motivated to make more videos like this. Okay, you are getting all this knowledge for free, as I'm dedicating to my busy schedule. I'm dedicating this time. So the only way that you can appreciate me is by liking this video, and most importantly, subscribing. And if you happen maybe to enjoy it, you can leave a comment. Feel free to leave a comment there in the comment section. I hope that you enjoy this lesson, and have a great time. Alright, so this is the A+ Academy app, where you find the remaining trigonometric function information. So when you come here on term 3, when you choose MA110 to select trigonometry, you'll find these video lessons which have been organized in order, starting from introduction where I've taught the basics and proving of identity. This way I've explained all the concepts that are very needed, and there are plenty of important videos. These videos are very short, don't be deceived. They are very short that you can easily finish them within 5 days. Okay, and you finish the whole tree. In the Moiva theorem has been taught. As you can see, these are complex, further complex numbers. These things come. Okay, graphing of cardioid, graphing of these trigonometric functions, these shapes, the petal rows, all these things, they have been simplified. Hyperbolic trig, everything is here. Okay, these are videos focusing on important things only. So the way that you download this app is that go on Play Store. Go here on Play Store, then search for A Plus Academy app. When you search for A Plus Academy app, you are going to find this app. So this is the A Plus Academy app. You can download it, or before you download, you can go through some reviews of students who have enjoyed using this app. You can come here and see reviews. You find great reviews from students who have benefited from this app. Okay, these are many reviews. In case maybe you are doubting, very soon you'll be among the students who will be testifying of how they will be helped. So download this app to access more of our video lessons. And on this app, actually, there are other topics which we have taught. Apart from trigonometry, there's calculus, even these other courses like physics, maths, everything are here. They're all A levels or non-NS work. It is here. Alright, so I hope that you enjoy this video. Let's start. So we have question 1. They're saying that using the identities, this identity and this identity, using these two identities, prove that this side is equal to the other side. So if you've watched the videos on the app where I taught the proving of identities, I say that they have given you have to show that this side is equal to the other side. So it will be up to you to choose which side are you going to take. Simplify it so that you end up with the other side. When you're proving the identities, you just need to pick one side. Simplify that side you've picked so that you can eventually end up with the other side. Okay, so here's how you do it. So now I gave you a tip in my video lessons that when you're proving identities, one of the trick which you use is pick the side that appears to be complicated. You always, they'll give you two sides. I know maybe there are three sides. I'm going to show you the question I'm talking about, but always pick that side which is appearing to be complex or complicated than the other. Get that side, simplify it to end up with that side which is appearing to be in a simpler version. Like in this situation, which side are we going to pick? So we are going to pick this side, right? Because this is even having something raised to a power of 2. So this is more complex than the other. Okay, so let's start solving with the first question. So right now we are on question 1. So these are the questions that we are having. Okay, this is the latest story sheet. So this is story sheet 12. These are the questions which I saw that they are relevant than others, because looking at what they have been bringing on the exam on trigonometry, they just like bring identity related stuff of the questions which are in that tutorial sheet 12 for trigonometry, the latest tutorial sheet. Okay, let us solve it. All right, so we need to simplify this so that we can end up with the other side. The other side is looking like how? Like 1 plus 2 sine theta cos theta, right? All right, this is what we are having. So our target is to end up with something looking like this. Now if you check the side which we've picked, in fact when you're solving on your exam, you can even say from left hand side to the right hand side so that your lecturer can know which side you've picked. Now you write it in your good handwriting, not this bad handwriting which I have. Okay, so I'm saying that if you look at what we've picked, for us to end up with what is on the other side, if you check at the left side, I mean the other side, it is not having power 2, right? So for us to get rid of power 2, we need to expand this. So we are going to expand this thing, okay? Because the target is not having power 2. So when you expand, simply by doing this, for those of you who don't know, when you expand this by doing this. Now me, I have a shortcut. I don't write like this. Okay. So you're going to end up having sine power 2 theta plus cos squared theta plus 2 sine theta times cos theta. Okay. Now, if you remember the identity, that this thing, what I'm just going to circle, these things, they are equal to 1. That identity, they have even given us in the question. So we are going to say that we are going to substitute this with 1. So eventually you're going to have 1 plus 2 sin theta cos theta. Okay. And if you're watching this video, don't forget to subscribe to the YouTube channel. Okay. Support the YouTube channel. Let the YouTube channel grow so that you can encourage me to make more of this kind of content for free on this YouTube channel. Okay. And this is what you have ended up with. So like you can see, we finally managed to end up with the other side. So by just doing this, you've proved. It's not like on De Morgan whereby when you prove from this side to the other side, you also start proving from this side to the other side. No, just pick one side, simplify it to end up with the other side. Okay, so the second identity that we have to prove is like 1 over cos theta minus cos theta. We need to show that this is equal to sin theta tan theta. Okay, so how do we do this? So like I said, we have two sides, right? Pick the side that appears to be complicated. Okay, listen, it's not always like a mandatory that you have to pick the complicated side. This is just a trick which I use because it's easier to simplify, to prove when you get the one that is complicated. Because you know the way it is, when you get the complicated one, all you need to do is simplify it. Now, if you get the one that is simplified than the other side, you find yourself in a situation whereby you start to like going backwards. You need to reverse it. You need to start reversing things so that you can end up with a complicated side. But if you get the one that is appearing complicated, all you need to do is just simplify, then boom, you end up with a simplified side. So like it's not always a mandatory, but if you want, if you just pick whichever side you think that you'll be able to handle and end up with the other side which you haven't picked. So like in this situation, this one seems to be like it's a little bit complex, right? Because it's having fractions minus what. So I'm just going to pick this side. So I'll say from left hand side to the right hand side. All right. So here what you do is this. So like you can see, we are aiming to end up with the other side, right? So for us to solve this question we are having like a fraction, like we have two things subtracting, right? But if you look at the final thing that you're having, it's not having anything subtracting. So this is a sign that whatever you're having this side, it should eventually end up as a single fraction. Okay, so we need to eventually end up with a single fraction, like one function, not two things. Like we just need to end up with one thing for us to end up with this. So this is a sign that we need to make that a single fraction. You should be thinking like this on your exam, okay, when you're solving any question on identity. And I think I've solved plenty of questions on proving identities on the app. There are videos there which I solved like tons of questions which they like bringing. Even hyperbolic trig, they bring identities there. It's just that unfortunately in the two tutorial sheets which you guys shared to me, tutorial sheet 12 and 13 for this year, there's no question on hyperbolic trig. But trust me, it is going to be there. So make sure that you watch the videos on the A Plus Academy app. You find the videos on hyperbolic trig. Okay, so let's make this a single fraction. So we have cos theta, right? Then we'll end up with 1. Then here we'll end up with cos theta squared, cos squared theta. Okay, now how can I end up with this? So remember this identity that sine power 2 plus cos power 2 theta is equal to 1. Do you remember this? Do you also remember that we used to simplify this in such a way that when we make sine theta the subject to a formula like this, we are going to end up with something like this. We are going to end up with 1 minus cos squared theta, right? So like this used to be an identity when you make sine squared theta the subject to the formula. Now, this also means that wherever there is this, you can substitute sine power 2 theta. Or wherever you're having this, wherever you're having sine squared theta, you can substitute with this. That's what it means when you say identity. So using this identity, you can agree with me that I'm going to substitute this with sine power 2 theta, right? So I'm going to say that sine power 2 theta over cos theta, right? Like we are almost there. Now, how can I end up with sine times tan theta? These two functions, they're like multiplying. Is there a way I can tweak this one to eventually end up with this? So like, you know the secret about proving identities, whenever you are proving, you need to be asking yourself, whenever you reach at any step, like, how can I simplify from here to end up with something looking like this? Like, that's when you'll be knowing what to do. That's when you'll be knowing whether to, maybe here I should factorize, here I should write them like this. They won't give you that, no, simplify in this way. It will be you thinking, okay? So like here, whenever you have sine power 2 theta, it is same as you're having sine theta times sine theta over cos theta. It's like you have two sine thetas multiplying, right? Okay, so now how do you move from here? So you know that this one, you can also write it as sine theta times sine theta over cos theta. Now, let me ask you this question. What is sine theta over cos theta? Sine theta over cos theta is tan theta, right? So I'm going to substitute them with tan theta. So I've just substituted this with tan theta because it is equivalent, or it is an identity for tan theta. Hence, we have proved. You can even say, hence, proven. Okay? Alright, so you've been given this question. This is now C, that cos A minus, we need to prove that this, actually try to observe this question. This time we're having three sides. there's the left side, the mid side, and the right side. So now we need to show that these are equal to each other. And the way that we do this is by, we are going to pick two sides. It can be any side. It can be the mid side, the left side, or the right side. Okay. So only pick two, then prove that those two are equal to the other one, the other. And that will be just up to you to choose the one that you manage to simplify to end up with one thing that you're going to choose. So me, in this video, I'm just going to pick this one. I'll be comparing these two against this one. So what I'm going to do is that I'm going to prove this, I'm going to get this and prove that it is equal to this one. So this will be my target, like it's the one that will be targeting to prove, to end up with. So I'm going to get this one. At first, I'll get this one, simplify it so that I can end up with this one. Then I'm going to get this one at middle, simplify it so that I can end up with this one. So let's start with the first one, which is cos power 2 minus sine power 2. I need to show that it is equal to 1 minus 2. Okay. So we need to show that this side is equal to the other side. So basically, right now, my goal is to end up with what I've just put in the box. So let's simplify now this. So we want to end up with this, right? The one that is having sine. But if you look at what we're initially having on the left side, we are having a cos here. So you need to think of an identity that we can substitute with this one, cos power 2a, that we can substitute with cos power 2a. And that thing that you substitute it with should have sine in it, because we want to get rid of cos, because in the final thing, we shouldn't have cos. So if you remember this identity, that sine power 2a plus cos power 2a is equal to 1, right? If we make cos power 2a, we are going to end up with 1 minus sine power 2a, right? So I'm going to get this and I'll put it here. So this is just an identity as we are driving. So I'll get this and substitute it here. So I'm going to now have 1 minus sine power 2a minus sine power 2a. Yeah, it is a. So this and these two are like terms, right? So I'm going to have 1 minus 2 sine 2a, right? Now, if you look at what I've just ended up with and what we're aiming to end up with, are they the same? Yes. So you can say, hence proved. Don't know if it's proven. Those of you guys who are advanced in English, only you guys will know the one which should be the one to write here. Hence proven. You guys, I don't know if it's proven, but I think this one makes much sense. Let me get rid of this. Hence proven. Okay, so let's now get so we've proved this one against this, right? Now let's prove the middle one against our target. So this time now, we prove that 2 cos power 2a minus 1 is equal to 1 minus 2 sine power 2a. Okay, so right now I'm proving that this is equal to this. So our target is this one, right? So if you look at our target is not having cost in it. It is having sign. So you need to come here and ask yourself, is there anywhere where I can substitute something to get rid of this cost? Because I don't want to have cost in my final expression. So you're going to think of possible identity that you're going to use. I think this is one of the powerful tips when you're proving. Those of you guys who struggle to prove identities, there's something that you don't know, and it is what I'm talking about right now. You should be thinking in this pattern. Okay, ask yourself, what can I substitute? Proving identities, it's the game of those trigonometric identities I taught in the video. In my video lessons, those identities which I taught, I think there's a special video where I showed you the important identities. Okay, so those identities are what you use everywhere. They are compound angles identities, all those identities I taught. Okay, so in this video I'm just applying the concepts. Okay, so now let's proceed. So here it's simple because right now we are only dealing with simple identities. So if you remember here, what are we having? The identity for cos A is what? 1 minus sine power 2a, right? Like I showed you. So let's just substitute here. So this time we're going to have 2 times 1 minus sine power 2a minus 1 multiply through 2 minus 2 sine power 2a minus 1. Okay, so let me take this on the other side, or let me just bring this on this side. Basically right now I'm just simplifying. Okay, so now we are having this 2 minus 1, it's 1, right? Eventually we are ending up with 1 minus 2 sine power 2a. So try to see, is this equivalent to this one? Yes, so we have proved. So just like this here, you are done. Now this is just question 1. These are the identities which were in story sheet 4. These were the identities which were there. Okay, let's go to question 2. So verify each of the following identities. They want us to verify each of the following identities. These questions are there in story sheet 13 for trigonometry. So they are saying verify each of the following identities. So let's start. There's A. So I'm going to be solving these one by one. So it's A, G on the other paper here. So on this other paper we are having up even GH. So from A to H, I'm solving all the questions which were there. Right now I'm focusing on what is very important, which is trigonometric equations and proving of identities. Right? So we have these, right? So let's start. Right. So this is the first identity. So they want us to prove that this is equal to this. So like I said, get the side that appears to be complicated, then start simplifying it. So in this situation, this is just one function, but the other one, it is 2 functions multiplying. So we can agree that this side is a little bit complicated compared to the other one, right? So I'm going to say sine theta times sec theta. I want to show that this is equal to that one. Now, how are we going to end up with tan theta? The way that I'm going to end up with tan theta is that I'm going to see, is there anywhere where I can substitute an identity, then eventually lead me to tan theta? Is there any identity we can substitute here? So if you remember, sec theta, it is same as having 1 over cos theta, right? This means that I can substitute sec theta with 1 over cos theta. So it's going to be sin theta times 1 over cos theta. Okay, so now it's going to be sin theta over cos theta. All right. So what do you do next? So what you do next here is that you're going to say, what is sin theta over cos theta? This is tan theta. So just like this, you've proven. Okay, so B is written like this: sin theta plus sin theta tan power 2 theta. We need to show that this is equal to tan theta. This is equal to tan theta times sec theta. Now, which side appears to be complicated than the other? It is this side, right? So I'm going to simplify this so that I can end up with the other side. So let's start. So I'm having, so first of all, how do you think we can simplify this? So if you see, this final thing that we are aiming for, that we are aiming to end up with, it is not having anything anywhere that is adding, right? It's just like two things multiplying, two functions multiplying. So I need to find ways to make this appear to be singular. So try to use your math now. If you look at this properly, I'm having side on this side and sign on this other thing, right? So I can factor this out. I can factor out sin theta. And here I'm going to remain with 1, right? Here I'm just going to remain with tan theta power 2. Now we're not done yet. We need to, if you look here, I'm having sec theta as well. So you need to think, is there any identity I can substitute with tan theta that has got sec theta, or anything that can lead me to sec in it? That's the question you're going to ask yourself. So if you remember, let me take you back now. When I was teaching the identities, let me take you back. Okay, if you remember this identity, let me put this in a box because I'm just trying to show you the identity I'm about to start using. So if you remember this identity, sin a plus cos power 2a is equal to 1. There was a time we used to say that I can divide through by cos power 2a throughout over cos power 2a over cos power 2a. Then when I simplify, sin power 2a over cos power 2a, it is going to give me tan power 2. Oh, since here we are using theta, instead of using letter a, let me just use theta. Okay, so sin over cos is going to be let me write it here. It's going to be tan power 2 theta. This into this, they'll cancel, right? Eventually we'll have 1. Then equal to 1 over cos power 2 theta. Now, cos power 2 theta. 1 over cos power 2 theta is what? Sec, right? It is sec. So it's going to be sec power 2 theta. Alright. So this is the identity we are going to use. Now, since we need to get rid of this tan theta power 2, we need to substitute this with something that will lead us to sec or anything that has to do with sec, right? Sec theta, something like that. And if you see, actually, do you know that tan power 2 theta plus 1, I can swap the positions whereby I can also write them as 1 plus tan theta so I don't know if you can see the identity which I'm about to use. So now look, I know what you're thinking. You're thinking of making tan power 2 theta the subject, which can be right. Okay. Actually, it is also right. There are two ways here. There are two possible ways you can approach this. If you want, you can make tan power 2 theta the subject, then substitute here, then simplify. You still end up with the person who's going to say, since 1 plus tan theta is equal to sec theta, and here I'm having 1 plus tan theta power 2, which is a, so mean that wherever I'm having 1 plus tan power 2 theta, I can substitute with sec power 2 theta. Even this method, even this approach, it will still work. This is mathematics. There are many ways to kill a rat. Okay, so I'm going to say sine theta. So me, I'm going to use the second approach. I'm just going to substitute this whole thing with what is on the other side, because it's equivalent to this and it is the same thing which I'm having here. So here I'm having sec power 2 theta. Okay, now we are not done yet. If you look at what I'm having here, it is tan theta times sec theta. Is there any way I can again rewrite this to eventually end up with the other side? So I'm going to do this. I can say sine theta times 1 over cos power 2 theta, right? This can also be written as, I think since I've run out of space, let me continue this on the next. Okay, let me try to see if I manage here. So this can also be written as sine theta times 1 over, you know that if you have power 2, it's like you have 2 cos thetas multiplying, right? Have you seen? So I can also write this as sine theta over cos theta times 1 over cos theta. What I've written here, it is the same as what we had here, also same as what we had here. Okay, so now our job is to substitute with the identities. So sine theta over cos theta is what? It is tan theta, right? Times 1 over cos theta, it is sec theta, right? So just like this, you have proven this one. It's proven. Okay, this is the question C. So they want you to show that this side is equal to the other side. Now you're going to pick the side which will appear to be complicated than the other. So if you check properly, the right side, this side, they appear to be in their simpler version, because sine x, these are simpler version of trigonometric functions, right? But if you look at this one, it is having sec tan x, and these compared to the other side, they appear to be more complicated, right? And also, I'm not saying it's a mandatory. If you're someone who can move from this to this, if you can get this side and manage to simplify it and end up with this, you can pick the other side. It's just that picking the complicated side, it is much easier. So I'll pick this side, the left side. Okay, like this. Now, since we need to eventually end up with sine x, we need to substitute with possible identities for this and this. That will eventually lead us to what? Lead us to sine x. So you know that tan x is same as having sine x over cos x, right? Minus, and you know that sec x is same as having 1 over cos x raised to the power of 2. Okay, and if you can see the final thing that we're having here, we are having like a single fraction, right? So, but here we're having two fractions. So before we even expand, let's make them a single fraction. So this into this is going to be, we are going to get back sine x, right? Minus this into this, we are going to get 1. Then we raise it to the power of 2, right? Now, we can try to apply this power 2. Let's now expand them. So we are going to have sine x minus 1 power 2 over cos power 2x. Now, you know that eventually I need to end up with sine x, right? So I'm going to think, what can I substitute with cos power 2x? That is having sine x, because I don't want to have cos x anywhere in my final expression. This is, the other side that you are comparing against. It is something that you should be looking at each time you move a step. You need to see, what can I do from here to end up with the other side, and try to see what is in the other side so that you can know the proper identities to use. Because in trig, there are some identities which may be, especially on the compound angles for cos, you find the same identity. It has the one for it has the one having cos only, it has the one having sine only. So depending with what you're looking for, will tell you the appropriate identity to use. So since I'm targeting the one having sine x, I'm going to say, remember that okay, recall, I think let me do it from here. I don't want to run out of space. Recall that sine power 2x plus cos power 2x is equal to 1, right? If I make cos power 2x the subject, then I have 1 minus sine power 2x this. I'm going to end up with this, right? So I can substitute this with this, because my major interest right now is having sine. So now we have sine x minus 1 power 2 over 1 minus sine power 2x. Okay. Okay. So what's the next thing? So right now, try to see at what you're having. Try to look at what you're having. We're having this, and we want to end up with this. So here it's quite tricky. So here's how you now move from here. So let me try to find ways in which I can make the numerator for this look like the numerator for what I'm aiming for. If you look at the numerator I'm currently having, the one that is having negative is 1, and the one that is having positive is sine x. But literally, the one that is supposed to have negative is sine x, right? Then the one that is supposed to have positive is 1. So what do? I'm going to factor out negative 1. When you factor out negative 1 from the numerator, negative 1 is going to go out, and it is going to go out with a power 2 because it's under power 2. Then here I'm going to remain with negative sign x plus 1 power 2. This is what you're going to have on the numerator when you factor out negative 1. This is a concept in mathematics for those of you guys who don't know it. When you're factoring out, let's say if I say I'm factoring out negative 1, it means negative 1, I'm dividing it throughout what is inside. When I divided by sine x, I ended up with negative sine x. Divided by when I divided by positive sine x, I ended up with negative sine x. When I divided by negative 1 itself, I ended up with positive 1. Then it went out. When it went out, since we are factoring out, it should go with whatever exponent is there. In this situation, it is power 2. Okay? Okay. So, for the numerator, this is the first step, right? Then now about the denominator, how are we going to simplify from here? Because if you look at it, it is having 1 minus sine power 2x. Now, if you look at what I'm having here as my denominator, I'm not having anything like power 8 sine power 2. I'm just having one sine. So meaning that I should also try to see what can I factor out here to at least end up with something that will look like 1 plus sine x. Now, for you guys who know maths or who have been watching my videos from day one, there's this concept I usually talk about, the method of completing the square method. So like using the method of completing the square method, what I'm having on the denominator, I can also write it like 1 times 1 minus, because this one is like I'm having sine x raised to the power of 2, in case you don't know. This is same as having sine x power 2. So times sine x. So this means that what I'm having here, it is same as what I'm having here. And what I'm having here, it is same as what I'm having here. So when do you use completing the square method? I think I've been talking about this whenever I teach. So completing the square method, you use it when you're subtracting, when you're finding the difference between two things or two figures or two numbers, two whatever they are, which were obtained by raising to the power of 2, by raising a certain value to the power of 2. That's when you apply this concept. So I've been written this now. Let's simplify the next step. So let's start by simplifying the numerator. You know that negative 1 power 2 will just give me 1. And it's better I don't even write it because it's just multiplying with this. Then this one is going to eventually, and look, I can rearrange this whereby I can say 1 minus sine x. Like I can swap the positions. So now I'm going to say 1 minus sine x. And now look, since it's power 2, it means that this thing, it is multiplying by itself, right? Twice. So this is, I don't know if I should say once, but it's like you have these things multiplying themselves like this. 1 minus sine x. So if I wanted, I would have just written one thing and raised to the power of 2. Or if I want, I can show that there are two things multiplying. Okay? So step 1, simplifying the numerator. Let's simplify the denominator as well. If you're not completing the square method, here it's going to be this minus this, right? It's going to be 1 minus sine x. And this plus this, 1 plus. So for you who are doubting, try to expand this denominator I'm having. Expand it, you end up with this. Okay, so now at this stage, you are going to ask yourself, is there anything that I can cancel? Is there one thing that is found on both numerator and denominator that I can cancel? Of course, this and this, right? I've just now remained with, let's write what we've remained with. So we've remained with 1 minus sine x over 1 plus sine x, right? So if you see, this, is it looking like what we're proving against this one or our target? Yes. So we have proven, okay, hence proven. All right. Where are we? That was C. Now let's go to D. Right. So right now we have this question. They want us to prove that this is equal to the other. So I'm sure you can see that this one is more complicated or complex than the other, right? Because here you just have one function, but here you have like two fractions. So since what we are aiming to end up with, it is something that is a single fraction. So this is D. So the first step that we are going to do is to make this a single fraction, because what we are aiming to end up with is a single fraction. So when to find the common denominator, we're going to multiply them. So it's going to be common denominator is sine x times 1 plus cos x. Okay, and then this into this, it's going to give us 1 plus cos x times 1 plus cos x. Then this into this is going to give us plus sine power 2x, because it's like power x raised to the power of 2. Okay, so this is same as having, so basically just expand this. Okay, so expand that. So when you expand this, when you multiply this and this, you are going to end up with 1 plus cos power 2x plus 2x, 2 cos x plus sine power 2x. Okay, over sine x. And take note that cosec is equal to 1 over sine. So as we are simplifying, keep in mind that I need to end with only sine on the denominator. Now, is there anything, because we need to find ways to get rid of some of the stuffs that are here on the numerator. We need to find ways to get rid. This is actually power 2. So what I'm going to do right now is I'm going to substitute this. If you want, you can substitute this one or this one. It's up to you. Both ways, some stuffs have to cancel. Okay. So if you remember, I think this time I won't show you how we are driving. By now, I'm sure you know. This is same as having 1 minus this, right? 1 minus cos power 2x. So I'm going to say 1 plus cos power 2x plus 2 cos x. I need to substitute this with what? With this, right? So plus 1 minus cos power 2x over sine x, right? So now we have 1 plus cos power 2x plus 2 cos x plus 1 minus cos power 2x and over sine x. Right. So you know that this will cancel this one, right? And also when I say this one will add with this one, 1 plus 1 to be 2. What are you going to remain with? 2 plus 2. In short, simplify the numerator. Right. So now let's simplify this so that we can end up with the other side. Okay. So let's factor out 2 on the numerator. What are we ending up with? Ending up with 1 plus cos x over sine x. Now, recall that we are aiming to end up with what? We are aiming to end up with 2 cosec x, right? And you know that cosec x is same as having 1 over sine x, right? So you need to ask yourself now, what do you think I can substitute with? So there's a mistake here. I stopped writing this. I don't know. I found myself not writing this. Have you seen on the next step I forgot to write 1 plus cos x. So let me just write it because it hasn't been cancelled. I'm sure those who are following, you must be surprised, like how come, where has 1 plus cos x gone? And don't even make a mistake of commenting in this video. You comment that, sir, where has 1 plus cos x gone? Like I just forgot to continue writing it. So like it is still here multiplying by sine x. I'm sure you remember we ended up with this when we were finding the common denominator. And if you have already commented in the comment section, just go and delete. I've corrected this, okay? I remember that thing should be there because it hasn't been cancelled. Okay, so this was the common denominator which we found when we were making it the single fraction. And after factoring out 2, we've ended up with this. Since we have something that we can cancel, right? This and this will cancel, and eventually we'll remain with 2 over sine x. And we can write this as 2 times 1 over sine x, right? Which is same as and recall that 1 over sine x is what? Cosec x, right? So we've proven. All right, so we're having this one. They want us to show that this is equal to this. So we pick the complicated side, which is this one. Now we want to simplify this so that we can end up with this. But what we're trying to end up with, it is having 2 things adding up, right? But this is just like a single thing, a single fraction. So we need to write this fraction in this form. Remember that there's a concept that whenever you have a plus b over c, you can also write this as a over c plus b over c. Have you seen? Okay, so meaning that in this situation, what I've been given here, I can also write it as sine x over sine x plus tan x over sine x. Have you seen? Okay, let's now simplify this. Sine into sine, it is what? 1, right? Plus, now recall that here it is same as having tan x over sine x. Now recall that tan x is sine x over cos x, right? Divide by sine x, right? And this thing here, we can also write it as sine x over cos x times 1 over sine x, right? Meaning that this and this will cancel out. So we now have 1 plus 1 over cos x, right? And recall that 1 over cos x is same as sec. So right now it's same as having 1 plus sec x. And just like this, you have proven. Let's go to F. Okay, so now we have this one. They are saying prove that this is equal to this. Prove the identity. So you are going to check using the trick which I've just taught you of picking the side which appears to be complex. So if you look at this, we're just having sine and cos, but here we're having sec and cosec. So this one is more simplified, right, compared to this. So this seems to be the complex side. So I'm going to pick the complex side, which is, so I'll say from right hand side to the left hand side. We are moving from here to here this time around. Okay, so what are we having? We are having sec x plus cosec x over sec x minus cosec x. All right, so what are you going to do right now? So what you do is that you are going to say we're having sec. Now we need to end up with sine and cos. So meaning that I'm going to substitute these with their simplest version of the identities, which will at least, or the identities of them which having at least sine and cos. So let's start. We have sec x. Sec x is same as having 1 over cos x plus cosec x, it is same as having 1 over sine x, right? Then even here I'll say 1 over minus 1 over sine x. Right, now at this the next stage is that let's simplify the numerator and denominator. What do I mean? Let's make the numerator a single fraction, then the denominator as well a single fraction. So let's start with the numerator. So I'm having 1 over cos x plus 1 over sine x. Common denominator is going to be cos x sine x. This is going to give us sine x plus cos x. Okay, so this is what I'm having as my numerator. My numerator. Let's come now to the denominator. Let's make it a single fraction. I hope you are following. So we have 1 over cos x minus 1 over sine x. Sine x. We're going to get sine x cos x. Okay, and what are we going to have next? So this is our new denominator, right? So my new denominator, my new numerator is this, my new denominator is this. So like this and this, they are like dividing, right? So it is same as I'm having sine x plus cos x over sine x plus over cos x sine x. It's like it is dividing by sine x minus it's like dividing by sine x minus cos x sine x, right? Okay. So I can also write this as sine x plus cos x over cos x sine x times, so these are going to swap, right? So cos x sine x is going to be on the numerator, then on the denominator I'm going to have sine x minus cos x. Okay, all right, what do we have next? So the next thing that we're having is that as you can see here, this and this can cancel out, right? And these two fractions are multiplying. When these and this cancel, we're going to end up with sine x plus cos x over sine x minus cos x. Makes sense, right? All right, I hope it makes sense. So if you look at where we are right now, try to compare with this side. Remember, we are moving from this side going to the other side. Okay, this and this, aren't they the same? So we've managed to move from here to here, right? So we can say hence proven. All right, so now let's proceed. We have G and H remaining. These are the only questions in your latest spreadsheets which are involving identities. Okay, so let's do G and H. All right, so this is G. They are saying prove the identity. So likewise, based on the strategy that I've given you, we are going to pick what? The side which appears to be more complicated than the other, which is the right side. So I'm going to say we are moving from right hand side to the left hand side. Okay, and then what's next? What now? The right hand side is cosec power 2 theta, right? Minus cot power 2 theta over sec power 2 theta, right? This is the right hand side. Now, given this side, if you look at what we are comparing against, it is this one. It is having cos. But what we're having right now, there's nowhere where there is cos. So for us to simplify this, let's substitute the identities with their simplest identical, I don't know how to say it, but with their simplest identities in their simplest form. So you know that cosec power 2 theta, it is same as I'm having 1 over sine power 2 theta minus, all right, so cot power 2 theta. So what is cot? Cot is cos power 2 theta over sine power 2 theta. Cot is the opposite of tan, for you who don't know. Then what is sec theta? I mean sec power 2 theta. It is same as I'm having 1 over cos power 2 theta. Okay, now how do we simplify this? The way that you're going to simplify this is make the numerator a single fraction, then divide by this. So let's make the numerator a single fraction. Theta minus cos power 2 theta sine power 2 theta over so right now we are going to make this our common denominator, because this is what they are having in common. Then meaning that we'll get back the same things on the numerator. So this thing now is the single fraction for the numerator, right? And we're going to say divide by this. So I'll say divide by 1 over cos theta. Okay, so now we have 1 minus cos power 2 theta over, and if you want to be very good at trigonometry or mathematics, if you're very behind right now, go and download the A Plus Academy app on Play Store. All right, so we are going to say times, this can also be written as cos power 2 theta over 1. Okay, so now we have this. Okay. Now, if you remember, our goal is to end up with just cos power 2 theta. So try to think. So that means that we need to find ways to get rid of sine power 2 theta, right? If you remember the identities I showed you, do you remember that sine power 2 theta it is same as having 1 minus cos power 2 theta? So this means that wherever there is this, I can substitute with this and vice versa. So where there is this, I'll put sine power 2 theta. So now I'm going to have sine power 2 theta over sine power 2 theta. Then on this side, times, not equals, times cos power 2 theta. This into this, they'll cancel, right? And you're just going to have 1 times cos power 2 theta, which simplest version is going to look like cos power 2 theta. You can even say hence proven. Okay, let's go to H. All right, so we have H, which is this question. They're saying prove the identity. So right now what I'm going to do is that I'm going to get the side which appears to be complex than the other. In this situation, it's the right hand side. So I'll move from the right hand side to the left hand side, and then after, so we are going to move from here to here. So let me write what we are having. We have got x minus cos x over cot x. Okay, so this is what we are having. Now let's simplify. As you can see, our target is to end up with this, right? And what we want to end up with is having sine x. So I need to substitute with possible identities that will give me sine x. So cot, let me substitute it with its identity, which is, identity for cos is, you know that identity for cot, it is cos over sine, right? Make sure that you know these important identities. So cot x is cos x over sine x minus cos x. So let's make it a single fraction. Common denominator is sine x. You're going to get cos x. that is positive cos x, not that, I don't know where that negative is coming from. Then this one is going to give us sine x times cos x. So this is just the numerator. This is just the numerator. Okay, I mean, what we've ended up with, we've just simplified the numerator. Now this numerator, we are dividing it by this one, cot x. So I'll say cos x minus sine x times cos x over sine x. So this is the numerator, right? Then we say divide by cot x. So recall that cot x is cos x over sine x, right? Okay, so we are going to right. So you know that you can also write this as, so you have cos x minus sine x cos x over sine x times sine x over cos x. So we're going to cancel this and this, and now we have cos x minus sine x cos x over cos x. Okay, so recall that whenever we are having a plus b over c, we can also write it as a over c plus b over c. So in this situation, I'm also going to write this in this format. So I can also write this as cos x over cos x plus sin x times cos x over cos x. So this and this will cancel, this will cancel. Eventually I'm going to have 1 minus sine x. And we've proven, because we've ended up with what we're having on the left hand side. So we can say hence proven. Right. So now let's move on. We are on this question. Okay, let's move on to questions involving equations. Questions involving equations. So there are some things here which I taught in the videos on the app, which I won't really be repeating. Okay, so this video is focused, like I said, it is focused on solving, not teaching. Okay, I hope you understand that. So there are some things which I won't be explaining from scratch. I'll be just focusing to show you how to solve each of these questions. Okay, so let's proceed. Let's start with these questions here. And these questions were in tutorial sheet 13. In case maybe you are following, these questions were in tutorial sheet 13. All right. So I'm going to get this and take it on the other side. We're having this question as our first question. So, and if you remember, when I was teaching you on equations, trigonometric equations, those who are using the app, go under trig, then look for the videos titled trigonometric equations. That's how I labeled them. So that's why you find like where I taught how to approach these kind of questions. So if you remember, I said in this situation, you are going to make the trigonometric function on this side alone, then the non-trig equation, or the non-trig function like this one, which is just a number, right? I'll take it on the other side. So I'm going to have 3 tan theta. When it goes on the other side, it's going to become a negative, right? 3 negative 3 square root of 3. So I need to just remain with tan theta on this side. This will cancel, right? So I have negative square root of 3. Okay. Now, how do you move from here? So the way that you move from here is that you're going to see you're going to find some people call it the helping angle, others call it a reference angle. It depends with who's teaching you. Okay, so we are going to find a reference or the helping angle. So the helping angle, to find it, you're going to ask yourself, for now, when you're looking for the helping angle, this negative won't play a huge role. Focus on this, not the sign. Then ask yourself, when I'm using tan, when does tan give me square root of 3? Like, what angle should be here for me to get square root of 3? This is something that I taught. So the angle that should be here for you to end up with square root of 3, that angle is 60. Here's why. Because if you remember, tan theta is the same as, it is same as having sin theta over cos theta, right? Since we've said it's 60, so if you use the method I showed you to find these angles without a calculator, sin 60 is equal to square root of 3 over 2 divided by cos 60 is equal to 1 over 2, right? So this can be written as 2 over 3 square root of 3 over 2 times 2 over 1. This and this will cancel, and eventually I'll have square root of 3. So this proves to us that 60 degrees is the one that will give us square root of 3 whenever we are having tan theta. So we know the reference angle. Now, how do we find the values of x? The values of theta. So you're going to draw this and identify the quadrants. So we have the first quadrant, second quadrant, third quadrant, and the fourth quadrant. Now, we need to know in which quadrant are we going to get the values of this theta. And what it will tell us is the sign that is here. We are having a negative sign. Since we are dealing with tan x, you're going to ask yourself, when is tan negative? Because here there is a negative. When is tan negative? So recall that common mnemonic, I'm sure everybody by now knows it, that all students take some people will be like, all students take coffee. Others will be like, all students take chivuku. All students take chiwantu. I don't know, anything that starts with letter C that will help you to remember. Okay, some will be like, all students take maybe cocaine. I don't know, whatever will help you to remember. Okay, so remember that all students take chivuku, right? This means that A is presenting O, right? Meaning that all of the trigonometric functions are positive in this one. Listen, we are interested where tan is negative. But in this one, only sign is positive, meaning that tan is what? Tan is negative in this one. But here, since t is here, it means tan is positive. But here, it means tan is what? Negative. So only cos is positive here. Look, here all are positive. Only sign is positive. Only tan is positive. Only cos is positive. So keep it in mind. Now we are looking for the quadrant where tan is negative, which are these two quadrants, the fourth quadrant and the second quadrant. And we've found the helping angle. We found the helping angle to be 60 degrees, right? Meaning that it is the angle from the x-axis depending with the quadrant where we are. Okay, so now let's start now mentioning the values for theta. So let's start with the second quadrant. So if we're having 60 here, the first value for theta is from here to here. Have you seen? So this distance, to find it, we are going to say 180 minus 60, right? Which is going to give us 120 degrees. When we say 180 minus 60 to find this distance. So we found the first value for theta. The helping angle is not something that you should quickly, like, you just find it and write it as your answer. It's not always that your helping angle will be the value, like the final answer. Let me give you a tip. The helping angle, the only situation where the helping angle that you find will be among the answers, will be among the values, is when here there's no negative, there's positive. When the sign that is here is positive, always the helping angle will be among the answers, because of, we are going to see when we move on to the next question, I think. So let's also find the distance from here to where? To here, like this distance. So we are going to say 360 minus 60 degrees, which is 300 degrees. So the second value is 300 degrees. Have you seen? So we found two values for theta. So just like this, you are done. Now let's move on. Right. So let's now look at this one, question B. So B is like 2 cos power 3 theta. So if you remember, we are going to take all the trigonometric functions on the left side, right? So this will become cos theta is equal to 0. So like right now, our job is to simplify. So how do we simplify this? Let us factor out cos theta. So I'm going to factor out cos theta, which is cos theta 2 cos power 2 theta minus 1 is equal to 0. Then now let's equate this to 0 and this to 0. So let me start with this. Say cos theta is equal to 0. Then the other thing that we're equating to 0 is 2 cos power 2 theta minus 1 is equal to 0. So I have 2 cos power 2 theta is equal to, when I take this on the other side, then divide by 2 cos power 2 theta 1 over 2. Okay, so here I'm going to come back to this one. Let's first finish up with this. So the first values for theta, we are going to find them from this one. Then the remaining values for theta, we'll find them with this one. So let's come here. So when does cos give us 0? Like, what angle do we, or are we supposed to have for cos to give us 0? So if you look at the quadrant, whenever you have 90 degrees, cos will give you 0, right? This also means that even if you have 270 degrees, cos will give you 0. So far, you know that the values for cos are 90 degrees, 270 degrees. Now, we aren't done yet. Okay? We are not done yet. What is remaining? We need to also find values for theta using this. So what are we going to do? We are going to say we need to make cos theta the subject. Since this is having, having cos power 2 theta, it is same as having cos theta raised to the power of 2 is equal to 1 over 2, just in case you didn't know. This means that we can remain with cos theta only by introducing square roots on both sides. And this square root is going to be like this because it is also covering numerator and denominator. Okay, so I'm going to have, and actually okay, let's proceed. So we have cos theta now is equal to, this is same as having square root of 1 for square root of 2. We can rationalize this one. Okay, before I go there, let me show you. So this will eventually leave us with 1 over square root of 2. Now, whenever you are in math, and you see that the value that you have ended up with is having square root on the denominator, make it a habit of rationalizing it. So when we rationalize this one, we multiply the numerator by square root of 2 and the denominator by the square root of 2. We are eventually ending up with cos theta being equal to square root of 2 over 2, right? Okay, so all right, so at least now we have something that is solvable. Now you're going to ask yourself, when does cos give us square root of 2 over 2? You're going to find that. And one more thing. Okay, let me not talk about it. Yeah. Okay, so I'm saying that to find the helping angle or the reference angle, you're going to ask yourself, when does cos give us square root of 2 over 2? Using the tricks which I taught on the app, you're going to find that theta is equal to 45 degrees, right? Now, since this is a positive, we're looking for the values that are in the quadrant where cos is positive. And one more thing, recall that in math there is this principle that whenever you introduce a square root, it is accompanied by plus or minus. So meaning that we're having two possible values here. We're having cos theta is equal to positive square root of 2 over 2, or cos theta is equal to negative square root of 2 over 2. So right now we found the helping angle for these two cases, because the only time we end up with this is when theta is 45 degrees. So you need to find the values when you're having a negative quadrant and when you're having a positive quadrant. So let's start with when you're having a positive quadrant. So I'll say when theta is positive square root of 2 over 2. So when we are in this situation, remember that mnemonic that all students take Chibuku, meaning that cos is positive in this quadrant and in this quadrant, provided that there is 45 here and 45 here. So meaning that the first value when theta is positive is 45 degrees itself, and also this 45 here. This 45 here. Now, this 45, you are going to calculate from here to here. It is going to be 360 minus 45, and that is going to give you 315. So the other value is 315 degrees. Now, what if when theta is negative. When theta is negative, we are going to focus in the quadrant where theta is negative. Remember, all students take codeine. All students take codeine. So it's going to be cos is negative in this quadrant and in this quadrant, provided that there is 45 here and provided that there is 45 here, right? So you are going to say 1, the first value you are going to say 1 from here to here, the first value of theta from here to here, it's going to be 180 minus 45. So theta is going to be 35. Then to find this distance, you're going to to find the second value for theta, you're going to find this distance. So this is going to be 180 plus 45. That is going to be 220, 225. So now let's write down now all the possible values for theta. So the possible values for theta, so the first one is 90 degrees, which we found. The second one, 270 degrees. These we found them from this. Then you followed by those you found in the positive quadrant, which were 45 degrees, 315 degrees. Then in the negative quadrant, you had that first no, not 35, but 135. My God, it should be 135, not 35. 35,225. So if you have commented in the comment section that sir, it is not supposed to be 35 but 135, delete that comment right now. Okay, so now let's write them in order. So starting from the smallest, 45 degrees, 90 degrees, 135 degrees, then which one, 225 degrees, 270 degrees, then probably 315 degrees. Okay, I hope you are following. All right, so in this situation you're going to ask yourself, is there a way in which we have this question, actually question C. So whenever you see an equation having two different functions, I think even on the app I explained this, that when you see that there are different functions like this, you need to try to ask yourself, is there any function that I can substitute with an identity to eventually end up with same things in the equation? Like in this situation, you know that the identity for cos power 2 theta is 1 minus sine power 2 theta. So meaning that I'm going to substitute cos power 2 theta with this. Okay, so I'm going to have 1 minus sine power 2 theta plus sine theta minus 2 equal to 0. Okay, so let's multiply throughout. So this time this, it will be that one, this will be negative 2 sine power 2 so sine power 2 theta plus sine theta minus 2 is equal to 0. Now you know that this is a negative, this is a positive, and they are the same things, meaning that they are going to cancel, right? So these two have cancelled. What have we remained with? We've remained with negative 2 sine power 2 theta plus sine theta is equal to 0. Okay, and then to solve this question, let's factor out what is common. Let's factor out sine theta so that we remained with 2 sine theta plus 1. Now let's start equating each of these stuffs to the number that is that side, which is 0. So we have sine theta is equal to 0. Then we have negative 2 sine theta plus 1 is equal to 0, right? So we have negative 2 sine theta, take negative 1 there, divide by negative 2, eventually you're going to end up with sine theta being equal to, actually this negative and negative will cancel out, so I'll end up with a positive here. Then eventually you're going to end up with 1 over 2. Okay, now let's start solving each one of these. So let's start with here. So if I ask you, let's look at the quadrant. When does sine give us 0? The only time when sine will give you 0 is when you have 0 degrees, 180 degrees, or 360 degrees. Okay, makes sense, right? But it's okay. Even if you want, you can just write 0 and 180. So my possible values for theta, they're going to be 0 degrees, 180 degrees, and 360 degrees. Now let's come here. Let's find the helping angle. What can be the value for theta for sine to give us 1 over 2? So for sine to give us 1 over 2, the helping angle has to be 30 degrees. So since there is positive here, our focus will be in the positive quadrant where sine is positive. So let's bring up the mnemonic. All students takes coffee. Okay, so sine is positive here and also in this quadrant. The helping angle is 30 degrees, right? All right, so from positive of x to the angle, that's the first value of theta, which is 30 degrees. Then from here to here, which is going to be 180 minus 30 degrees, it's going to be 150 degrees. So we have that one, we have this one. All right. All right, so to write the final answers, you're going to say 0 degrees followed by 30 degrees followed by 150 degrees, then 180 degrees, then 360 degrees. Makes sense, right? Okay, let's move on. This is C. Let's go to D. So for D, we are having cosec theta minus cosec, right? Let me just check. Okay, D is cosec power 2 theta minus cosec theta minus 2. Now, for you to solve an equation successfully, the only thing that you should at least remain with, the only trigonometric functions that you should at least aim to remain with is maybe sine, cos, and tan. Yeah, only these three. So if you're having anything, try to find the identities that you can substitute to end up with any of these three, or to end up with cos and sine where possible. So like in our situation here, you know that cosec, it is same as having 1 over, since here we have cosec power 2, we are going to same as having 1 sine power 2 theta minus 1 over sine power 2 theta minus 2, right? Then we multiply through by we're going to multiply throughout by, look, our goal right now is to end up with a single equation. I mean, to end up with an equation that is not having any fractions. So to get rid of fractions, we are going to multiply through by, no, actually, since here there's no power 2, there shouldn't be power 2 here. We're just going to have sine theta, not sine power 2 theta. I thought that there is also power 2. So we are going to multiply throughout the whole equation. We are going to multiply it. We are going to multiply throughout by sine power 2 theta. So multiply sine power 2 theta to the rest of the equation. That's going to be, here there will be 1 minus sine theta minus 2 sine power 2 theta is equal to 0. Okay. Now, what do we have here? Let's arrange them properly. I can start with 2 sine power 2 theta minus sine theta plus 1. So we are having some sort of a quadratic equation. So what I'm going to do is that I'm going to say that P is equal to sine theta. Okay. So wherever there is sine theta, I'm going to put P. So now we have 2P power 2 minus P plus 1 is equal to 0. So we have a quadratic function, right? So let's find the common factor. What do you call them? The factors, right? So you know that the product is -2, the sum is -1. What are some of the two things that we can multiply to get -2? So let's say, I mean, when we sum them, they should give us -1. So this has to be negative, right? So I'm going to say -2p power 2 minus 2p plus p plus 1. Makes sense, right? So right now I'm going to group them like this. Then here let me factor out -2p. Then here I'm going to remain with p, right? Then here I'll have +1. Here I'll just factor out +1 so that I can have p plus 1. So eventually I'm going to end up with 2p plus 1 times p plus 1. Now let's solve for p. This question is just like it's involving a little bit, but we're going to undo it. So I'm going to say that let's get this and equate it to 0. So -2p -1, right, over -2 over -2. So eventually p is going to be equal to 1 over 2. So we get this -2p plus 1 equated to 0. No, we've solved for that one, right? I got. So let's get this one. We say p plus 1 is equal to 0. So p is equal to negative 1, right? Okay, now we have values of p, but we haven't found the values for theta. How are we going to find theta? So for us to find theta, what we are going to do is that we are going to say that we are going to find the value for theta when p is equal to 1 over 2. Then when we are done, we're also going to find the value for theta when p is equal to negative 1. All right. So say when we are having p is equal to 1 over 2, and also we are having p is equal to negative 1. So let's start with p is equal to 1 over 2. So I'm going to say when p is equal to 1 over 2, recall that theta is equal to, recall that, look, if you remember, we said that p is equal to sine theta, right? So let's substitute p with sine theta. So you're going to say sine theta is equal to 1 over 2. Now let's solve this one. So when does sine give us 1 over 2? The only time when sine will give us 1 over 2 is when theta is 30 degrees. When theta is 30 degrees, that's when sine will give us 1 over 2. So we know the helping angle, but if you look properly, this is a positive, right? So far, you know the helping angle is 30 degrees. Let's draw the quadrants. So you know that all students take Chibuku, meaning that we're looking for the quadrants where sine is positive, right? Here, sine is positive, so we have the helping angle here, and also here. So the first value for theta is 30 degrees, which is in the first quadrant. The second value is from this position to this position, which is simply 180 minus 30. That's going to give us what? 150. So these are the values for theta when p is equal to 1 over 2. Now, what if p is equal to negative 1? When p is equal to negative 1, what do you think will be the values for theta? So you're going to say that sine theta is equal to negative 1, right? So you're going to ask yourself, when does sine, so focus on this value to find the helping angle. When does sine give us 1? The only time when sine will give you 1 is when you have 90 degrees. So if I were to draw the quadrant, it's when you have 90 degrees. Now we have a negative here. We want a quadrant where sine is negative. So let's say all students takes coffee. So we want where sine is what? We want where sine is negative because of this sign. In the first quadrant, sine is positive. Even in the second quadrant, sine is positive. So the value for theta won't be 90 degrees because 90 degrees is in a quadrant where sine is positive. So what you're going to do is that you are going to go in a quadrant where it is negative, which is the third quadrant. So you have 270. So the value for, from here to here, That's where 90 is, 90 degrees. Well, let me just do this, 90 degrees. So the value is going to be 270 degrees. So this is the only value. So all the values are theta is equal to, the first one is 30 degrees, the second one is 150 degrees, the third one is 270 degrees. Makes sense, right? All right. So right now, what we're going to do is that we're going to say all right. So code power 2 theta. So like this is the equation they want you to solve for theta. Now, like I told you that whenever you see an equation which is not having cos, tan, or sine, it is having these other identities like cot, sec, what. Think of an identity that you can substitute to end up with these simple trigonometric functions like cos, sine, and tan. Yes. So like in this situation, the one that we are going to like deal with is cot, because cot, like, it's not among those simple ones which include sine, cos, and tan. I'm repeating these statements because I don't want you to forget. That's why I'm saying them over and over again. So recall that cot power 2 theta, it is same as having cos power 2 theta, right, over sine power 2 theta minus cos theta is equal to 0, right? So we're going to multiply throughout by, like, right now we're trying to end up with an equation that is not having any fractions. So I'll multiply throughout by sine power 2 theta. When I multiply it throughout, I'm going to eventually end up having, here I'll just end up with cos power 2 theta minus cos theta times sine power 2 theta is equal to 0. Okay, so right now we need to solve for theta, right? So let's try to factor out what is common. All right, so I'll factor out what is common, which is cos theta, right? And here I'll just remain with cos theta minus okay, so sine power 2 theta. All right, so now what we're going to do is that, now recall I told you that I think on the videos that are on the app, there was a tip which I gave you that try to find where you can substitute. Like whenever you have an equation, try to see where you can substitute to end up with like same type of functions. Like in this situation, we have in cos functions and sine function, right? Like try to see where you can substitute to just end up with one type. For example, to either remain with only functions for sine or only functions for cos. Like in this situation, we want to at least end up with only functions for cos instead of having sine. So like try to think of an identity which you can substitute with sine power 2 theta, that identity which will only have cos, not sine in it. And I'm sure by now you remember that sine power 2 theta is same as having 1 minus cos power 2 theta, right? So right now what you're going to do is that you're going to say cos theta times cos theta minus, when I substitute here, I'm going to have 1 minus cos power 2 theta. That's why, like, I have a lot to explain. It's just that this video is made for like just solving, but I'm even trying to explain. That's why, like, on the app, the videos that are on the app, I used to find time to like dedicate just to explain. There are some tips which I give when solving equations that you should know. With the tips which I give, I don't expect any of my students to fail any question on trigonometry. Trust me. If you are my student to even watch my videos, then you're struggling to solve, then I don't know what's wrong with you. Because like I gave all the tips. Okay, so let's proceed. This is what we're having. Okay. So let's now simplify here. So we are having cos. Alright, so we have cos theta. Let me just do this. Then we have cos theta. Negative times 1 is going to be negative 1, right? Negative times this negative is going to be positive. Cos power 2 theta equal to equal to 0. So what I'm having here inside the brackets, let me arrange them properly in a quadratic function way. Cos theta. So let's start with the one having power 2. Cos power 2 theta plus cos theta minus 1. Okay, so we're going to now equate them one by one. We solve for theta now. So we have cos theta is equal to 0. And also we are going to have cos power 2 theta plus cos theta minus 1 is equal to 0. Makes sense, right? So right now we are going to solve each one of these equations. I'm sure by now you know how to go about this. Let's start with this one. When does cos give us 0? Cos, I'm sure by now you know that cos give us 0 whenever we have 90 degrees and 270 degrees. So we have found some values for theta. Let's come here. So here it is tricky. So this question, it is requiring us to like use a calculator. You need to use the bus formula, then use a calculator somewhere. Okay. So you are going to use the bus formula where A is 1, B is 1, and C is negative 1. And you are going to do that to find the value for cos theta, which is going to give you, by now you know how to use the quadratic formula and all those stuff. So like I don't want to do everything from scratch. Already the video is long, and those things will just make the video to be unnecessarily long. Right, so we have this. All right, so now you know, first of all, before I even go anywhere, on the exam they won't give you this kind of a question. Usually, like from what I've been observing, the questions which they have been given are the questions which don't lead you to using a quadratic formula, because you need the calculator to solve, and you guys, using a calculator is not allowed. So on the exam they won't give you any question involving using a calculator. You know, in the tutorial sheet, let me tell you something. Tutorial sheet questions usually you'll be finding questions which I require you to use a calculator to just solve. The reason why they do that is because tutorial sheet questions are meant to just, for practice. Of course, they get some questions from there, but there are other questions which like they are not that much, like they can't bring a question phrased in this way. They just want you to like practice, and while you're practicing, you're just there at your BH practicing. You might use a calculator, right? So like they just maybe added this question so that they can just say you using a calculator maybe while you're practicing. But on the exam, they can't bring a question involving using a calculator. But this one, we have no other option but to use a calculator. And we are going to end up having cos theta is equal to either, it's going to be either negative 0.618 or positive 0.618. Okay, so you're going to find theta when it is this and when it is this. So the helping angle, to find the helping angle, you're going to use the inverse, cos inverse. The inverse of cos. That's when you're going to find the angle. They are on your calculator. And you're going to find that the helping angle is going to be 51.8. And when you're having a negative, let's start with the negative. When you're having a negative, when the value is negative 0.618, and you look at the quadrant, meaning that you're going to look into in the quadrant where cos is negative, right? Which is the second and third quadrant. So here there's going to be 51.8. So from here to here and also from here to there. So the values that you're going to get here, they will be 128 degrees, 0.2 degrees, and 231.8 degrees. So these are the values when you're having negative 0.618, but when you're having positive 0.618, when you draw the quadrant, you're looking at the quadrants where it is positive. This is going to be 51.8. 51.8, 51.8. So these are the helping angles. So the values are going to be 51.8 and 308.2. All right. So now all the possible values now, they are going to be, just list all of these that we found. All right. So there's this question which is challenging to most of the students, whereby they have told you that find theta. So whenever you see that you're having two different functions in an equation, remember I said that whenever you're having two different functions in an equation, think of an identity that you can substitute with, right? Now there are some cases like this whereby you can't think of like a standard identity which you can substitute with this and this, and none of them are having anything like sine power 2, and also they are not equations like cot, sec, cosec. They are simply sine and cos. Whenever you see a situation like this, group the trigonometric functions on a single side or on a certain side, then those which are not trigonometric functions like 1, put it on the other side. Okay, and then introduce power 2 to both sides. So when you expand this, you're going to end up with sine power 2 theta minus cos power 2 theta is equal to 1. Okay, and then because if you raise no, actually I've forgotten something. So sine power 2 theta minus cos power 2 theta. No, this is supposed to be plus. Then here there's going to be minus 2 sine theta times cos theta, then equate to 1. Yes, so this side is what we are going to have when we expand this, and when we expand this we are going to just have 1. Okay, just so like this. And then so here you are going to think of identities now. now we have an expression where we can substitute identities. So if you remember, an identity that presents sine power 2 theta plus cos power 2 theta is 1, right? And also, if you remember, an identity that presents for, I don't know if you remember on compound angles, identities for sine. This whenever you have sine 2 theta, it is same as you have 2 sine theta cos theta. Do you remember? So I'm going to substitute this with this. So let's start. So this one I'll substitute with 1, its identity. Then I'll say minus. Then this one I'll substitute with what? I'll substitute with this one I'll substitute with sine 2 theta equal to 1. Okay, so I'll take this on the other side. I'm going to remain with negative. Sine 2 theta is equal to 1 minus 1. That will be 0, right? So it will be 0. Sine 2 theta is equal to 0 over negative 1 over negative 1. Still, we are going to end up with sine 2 theta equal to 0. Makes sense, right? Okay, so what do we do next? So what we do next now is that we are going to say that first of all, you are going to ask yourself, when does sine give you 0? Whenever you have what a, the first value is when you have 0 degrees, right? What's the second value? When you have 180 degrees here. Now there is 2, so you're going to say 180 divided by, okay, or let me do this. You're going to say 2 theta is equal to 180. So over 2 over 2, theta is what? 90. So when there's 2 here, theta has to be 90 so that it can be 180 to give us 0. So the second value is 90. What other value? Even 360. So I'm going to say 2 theta is equal to 360. Then we solve for theta. This is going to give us 180. So even 180 degrees. So these are the possible values for this one. All right, so now we are just remaining with a few last questions, which are these. And one more tip, when I don't know if you've observed, I was using degrees instead of radians. What will tell you whether to leave your answers in degrees or radians is this range which they like putting. If the range which they have put here, they have said from 0 degrees, they have said theta has to be between 0 degrees to 360 degrees. If the values have been written in degrees here on this scale, even you, as you are solving, leave your answers in degrees. But if you look at the questions which you are about to start solving, this one they said if the values of x are between 0 to 2 pi. So if you see this range, the values are written in radians. Even you, the answers, you should be leaving them in radians. All right, so I hope that you guys have enjoyed. So let's move on to the next question.
Too many notes, I'm never gonna finish this! Enter the A+ Academy app. Learn physics, chem, math, and bio at my own pace.
All right, so we have question 13 from tutorial sheet 13. Find all solutions of each of the following equations. Express your solutions in radians. So we have these equations. Okay, now here they have said if the value of x is from 0 to 2 pi, so they are telling us that our values should be written not in degrees but in radians. Okay, So let's solve this first bunch of questions. I think this question is similar to what we solved, right? If you remember, I said if you have two functions, like in the equation, you have two different functions, which like you can't think of a possible like a possible standard identity that you can substitute with any of these functions. Like in this situation, we have sine and cos, right? In this situation, you can just raise both sides to the power of 2. Okay, so here I'm going to have sine let me do this. I'm going to have sine power 2x plus cos power 2x plus 2 sine x cos x. Okay, then you say equals. If you raise this to the power of 2, what are you going to have? You're going to have 2, right? Okay, so now we are going to think of the possible identities. If you remember, this one, it is equal to 1, right? Then this one, this is going to be equal to, this one is equal to 1. If you remember the identities, this one is equal to sine 2x, right? So if we substitute those identities, you're going to eventually remain with 1 plus sine 2x is equal to 2. Makes sense, right? Now I'll take 1 on the other side. So on the left side, I'll remain with sine 2x is equal to 2 minus 1, right? Then I have sine 2x is equal to 1. Okay? So now you're going to ask yourself, what can I put here? What can I put here for me to, for sine to give me 1? So first of all, you know that sine, okay, when does sine give you 1? Sine will give you 1 when the angle that is here is probably 90 degrees, right? When it is 90 degrees. Now, since there is 2 here, you're going to say 2x divided by 2 divided by 2. So the value of x is going to be 45. So meaning that here we have to put 45 degrees as our theta. Makes sense, right? Now, 45 in radians, we write it as pi over 4. Because you need to present your answers in radians. Okay. Now, since here is positive, it means we are interested in which quadrant? We are interested in, so what's the open angle? The open angle is 45. So since this is positive, we need those quadrants where sine is positive. Remember that all students take Q12. So in which quadrant are you going to find that? In which quadrant are you going to find sine is positive? In the first quadrant, right? Provided that here is 45 degrees, then also in this quadrant here. Now, for the second quadrant, we need to find the distance from here to here, right? So we are going to say pi actually is 180. So basically I'm trying to say 180 minus 45. So pi minus pi over 4. So this into this, so we'll get 4 pi, right? 1. So this is going to give us 3 pi over 4. So the values of this one are the following. The first one is pi over 4, then 3 pi over 4, right? Just like this, you're done. Let's move on to the next question. All right. So we have a question here, question B. solve for x. So like I told you, whenever you see an equation and it is having these kind of trigonometric functions like sec, tan, especially if tan and is combined with like a different function. But if maybe this wasn't here, maybe there was like just tan alone in the whole function, we would have proceeded and solved. Now, since it is combined with this sec, we need to find identities which we can substitute with these two. Okay, listen, the key here is that some equations will require you to just solve directly. Other equations will require you to simplify a little bit. Other equations will require you to simplify a little bit before you solve. I don't know if you've observed, especially these equations which are having these from trigonometric functions, like they are combined. Usually you find that first simplify, then solve. I hope that you've observed. Just that this video is not about teaching, it is about solving. But if you've watched the videos which are on A Plus Academy app, that's where I taught. Like there are some tricks which I learned, which helped me like to reach a level whereby I can solve any question on trigonometric equations, because there are some tips which I learned over time. So all those things I've shared them on the A Plus Academy app. So make sure that you also watch those videos. Don't abandon them for this one. Okay. So let's proceed. So we have done x plus 1. So I said that we need to substitute with the identities, right? So you know that tan x is equal to sine x over cos x, right? Then what? Then plus 1 is equal to, you know that sec x is equal to 1 over cos x. So we want to get rid of fractions, so we'll multiply throughout by the common fraction. I mean the common denominator is cos x, right? So make it a habit, multiply throughout by the common denominator of those which are having fractions. So here you're going to end up remaining with sine x plus, no, here there will be, yeah, I don't know, I got confused. Yeah, so there I'll remain with sine x plus cos x is equal to 1. Right? So if you remember, in this situation, what do? We raise both sides to the power of 2. Is this a question someone sent? Someone, I mean, like 2 people. I don't know if they okay, like I'm not really sure, but 2 people sent this question in my DM that this is from the tutorial sheet, kindly asking if you can. And you guys, I don't know if you watch my videos on the app, because you guys who have the app, like who have access to the videos on the app, like I don't expect you to fail to answer any question on on in the tutorial sheet, like these equations, because like I have taught everything, literally like everything. So if you're watching this video, those 2, it's actually a girl and a boy, they asked me this question. So if you're watching this video, I hope that you understand. Okay, I hope that you'll be able to solve this question. So when you raise both sides to the power of 2, expand this, you're going to have sine power 2 x plus cos power 2 x is equal to 1. No, I haven't finished the expanding, so it's going to be, okay, let me just write it on the next line. I forgot to write something, so I'm saying it's going to be sine power 2 x, right, plus cos power 2 x, then plus 2 sine x cos x is equal to 1, right? So we substitute with the identities like we have been doing. So here I'll substitute 1, here I'll substitute sine 2x. So eventually I'm going to have 1 plus, and this is similar to what we've solved, right? Okay, so I have 1 plus 2 sine 2 sine 2x. So I'll take this one on the other side, and I'm going to remain with sine 2x is equal to 1 minus 1. I don't even know how I'm showing this. So let's go. 2 sine 2x is equal to 0. Where is that 2 coming from? This 2 is not supposed to be part of the it's part of the identity. It shouldn't accompany this. This should just be alone like this. Yes, so they ignore the 2 that I was writing. Like, I thought maybe this was the coefficient. I don't know, in my head I thought like we have a coefficient this time, but there's no coefficient. Okay, so this is just part of the identity, because this is equal to the whole thing that is here. That's why I've substituted this with the O identity. Okay, no, I hope you haven't gotten confused. Now let's find the value of x. So when you need to ask yourself, when does sine become 0? Sine becomes 0 when theta is 0, when the angle that is here is 0. So the first value is 0, because there's no need to even do anything like anything. Then so at 0 degrees, this also means that it can also be 0 if sine is having the angle of what? 180. Now since there is 2x here, we are going to say 2x is equal to 180 over 2 over 2. X is equal to 2 into 180 is what? 90, right? So the other angle is 90 degrees. Now let's hope now listen, I'm writing like this because I want you to understand. Now you need to be writing your answers in radians. Okay, so in radians the values are going to present them like this: 0, pi over 2, which is 90 degrees. Or if you want, instead of showing this, in case maybe you want to show your work, don't show, if you like a question like this whereby they have asked you in radians, when showing your work, show everything in radians as well. I think I'll be doing that so that you guys can see how it is done practically. Okay, so here you would have done it like this: 180 is equal to pi, right, over 2 over 2. X is equal to pi over 2, not 20. Pi over 2. I don't know how I've written this 0. Like, seriously, where does it come from? So 0 and pi over 2 are the final answers. Okay, so I hope that those who asked that question have understood, and I remember the names of the people who asked me that question. So the first person was Mutale, a guy by the name of Mutale. Then another girl by the name of Pulu. I've remembered your names because students think that just because they are a lot, like I have a lot of students, so students think that I don't like know them. Like, as long as I've chatted with you before, like we've had the chat before, I've mastered your the details of your account. And I remember how I chat with everyone, but I talk to a lot of students. Like every day I talk to about 30, between 30 to 40 students. And like I remember every chat that we are having. So if you've ever chatted with me, just know that I mastered your contact details, not the phone number necessarily, but the name. Okay, so Chipulu and Mutale, if you are watching this, make sure that you comment that, sir, I've understood. Okay, so let's proceed to question C. We have done power 2 theta is equal to 3. Let's solve this one. Now You know that whenever you have something like this, tan power 2 theta, it is same as you are having tan theta raised to the power of 2, right? Now, how do we get rid of this power? Because we just need to remain with tan theta. So someone will be like, but sir, you said if you have things like tan, you have to substitute with an identity. You only do that if tan theta, if tan is combined with these other functions. You can try to like think of maybe substituting, like maybe cosec, all those things. But whereby it is just alone. If you see functions like sine, cos, tan, these you don't need to think of identities to substitute with, because usually they are easy to work with. Okay. But if you see the combination of maybe cosec, cot, what, try to see why you can simplify a bit before you solve. All right, so introduce square root on both sides so that you can cancel this power 2, and you're going to remain with tan theta is equal to square root of 3. So to find the angle, you're going to ask yourself, what are you going to ask yourself? You're going to ask yourself, when does tan give us square root of 3? When does it give us square root of 3? I just want to make sure I'm solving the right question. So you get square root of 3 when you are having, when theta is what? 60 degrees, which in radians is written as pi over 3. Makes sense, right? All right, let's proceed. So what do you do next? Draw. You need to show try to check the quadrants. Since here it is positive, we need only the quadrants where tan is positive. Remember, all students take H12. Okay, where is tan? Tan is here, so here it is positive. This is our area of interest, and also here, right, pi over 3. Even that one is our area of interest. Okay, so the first value is going to be this one, because from the positive of x-axis to where the first helping angle is, we are having what? We are just having pi over 3. Okay, and then from the positive of x to where the other helping angle is, it's going to be like this: 180 plus pi over 3. So when you sum them up, having, so it's going to be 3 pi plus pi, that is going to be 4 pi over 3 pi. So the two values are these: 4 pi over 3. Makes sense, right? Okay, so let's move on to question D. All right, so we have another question here. So like we are having three functions, right? Two functions, sine and tan, and they have been like put in the same equation, and these like they are friendly functions to work with, right? So let me just take sine on the other side, because if you remember the principle which I taught, that normalize, making sure that trigonometric functions, they are on this side. They shouldn't be like on different sides. They should be on the same side. So let's write like this: tan power 2 theta. This one will bring it on this side. Okay, then we factor out tan. We factored out tan theta, right? So we've remained with tan theta minus 1. So let's now get this and equate it to 0. Sin theta is equal to 0. Then let's get what is in the brackets. Then we also equate it to 0. Tan power 2 theta minus 1 is equal to 0. Okay, so this one going to be some work, right? All right. So let's make tan. You know that this is same as having tan theta power 2, right? I mean, is equal to 1. So we can square both sides, right? Then we've remained with tan theta is equal to plus or minus 1. So you know that in math, whenever you introduce a square root, it becomes plus or minus. So we are going to have plus or minus 1, right? So let's start with this side. So this one is going to be it's going to be a little bit hectic, right? So let's start here. So when does sine give us 0? Sine give us 0. So sine give us 0 when theta is 0. So the first solutions which are finding are these. So 0. Then so 0 is here. Then it can also give us 0 if theta is 180, right? Also, if theta is 360 degrees, it can give us 0. So when we are having 180 degrees, which in radians we write as pi. Also, when you're having that's 360, 2 pi. But if you want, you can just end at pi. But these are the possible values which we can give them. All right, let's come here now. So here we'll start when we're having a positive value, positive 1. Okay. When you're having a positive 1, so you need to ask yourself, when does tan give us 1? Tan will give us 1 when we are having how many degrees? 45 degrees, right? Since it's positive, we are focused in the positive quadrants. So that is if we have 45 degrees. In radians, we write it as pi over 4, right? So even here, I'll say pi over 4. Okay. So the possible values are these. So the first possible value is pi over 4. The other one is pi plus pi over 4. 4 pi, right? Plus pi. That's going to be 5 pi. So 5 pi over 4. Right. So we have 5 pi over 4. So what if maybe it is negative? This time the helping angle will be the same, but we're just going to look at the different quadrants. So this time you're looking at in the negative quadrants, right? So the quadrants where tan is negative, guys, I'm using a free hand, and me, I'm not that kind of an artistic guy, so the lines they are usually bent. They are bent. So 45 degrees. 45 degrees. Okay, so the first value is going to be from here to where? To here, right? That's going to be pi minus pi over 4. Pi, that's going to be 3 pi over 4. And then from here to this angle here, it's going to be 360, which is 2 pi minus pi over 4. That's going to be 8 pi, right? That's going to be minus 4 pi. Here we're going to have, what are we having? 7 pi, right? Over 4. Okay. So now, what are the values? So all the values together, you need to list them. This. Then you come here, you list this. And here we have two values. So list them. The values, the solutions are these. 1, 2, 3. Or here we listed them. And also these ones here. These are your solutions. At the end, make sure that you list them. Right. So we have this question. I think it is the last question, if I'm not mistaken. Yes. So they want you to find theta. So I'm going to get, I don't know. I think this is the third time. I don't know if it is the fourth time I'm saying normalize.
First-year courses stressing you out? Get access to solved materials and video lessons in all your subjects. Download the A+ Academy app and learn at your own pace.
Right. So let's solve the last question. So in this situation, we're going to, if you remember, I said normalize, making sure that the trigonometric functions are on the left side alone. Okay, so I'll take this on the other side. So initially here we're having this thing to become minus cos theta. All right, so cos theta, cosec theta is equal to 0. So we have, so let's substitute this with its identity. You know that cosec is 1 over sine, right? Minus cos theta times 1 over sine, right? Right, so let's multiply throughout by sine theta. We want to get rid of the fraction, so I'm going to multiply throughout by sine theta. So here you're going to have 2 cos theta minus cos theta just. Okay, so what do we do next? So we're going to, actually here there should be sine theta here. Let me write it properly because we multiply this throughout, so this need to have sine theta. So it's going to be 2 cos theta sine theta minus cos theta. Okay, so what do we do next? So what we're going to do next is that we are going to factor out cos theta. We are going to remain with 2 sine theta minus 1. So we get this cos theta equated to 0, and we get 2 sine theta minus 1 equal to 0. Then we're going to have 2 sine theta is equal to 1. Okay, so divide through by 2 over 2. Then we now have sine theta is equal to 1 over 2. So when does cos give us 0? So cos give us 0 when we have 90 degrees, which is pi over 2, and when we have 270 degrees, since we are, you have to present your answers in radians, this is 3 pi over 2. Okay, and then here, when does sine give us 1 over 2 is when you have 30 degrees. which is written as pi over 6. So since there's positive here, we're interested in the quadrants where sign is what? Sign is positive, which is the first quadrant and the second quadrant. Pi over 6, pi over 6, right? Right. So the first value is already this one here. The second value is from here to here. So we're going to say pi minus pi over 6. So we have over 6. 6 pi minus pi. That's going to be 5 pi over 6. Now let's put them all together. So we have for the solutions going to be pi over 2, 3 pi over 2, pi over 6, 5 pi over 6. Right, we have these. Now here, these are the solutions. So this is the last question, and if you've made it this far, first of all, make sure that you've subscribed to the YouTube channel, because you've benefited a lot for free. And the only way you can pay me is by subscribing, okay? Even though YouTube does not pay anything, but just to see you supporting the YouTube channel, okay? In case you don't know, YouTube does not pay in Zambia, so stop feeling stingy to just click a subscribe button. Yes. And then also, whatever you've learned so far is just 20% of trigonometry, okay? There's more about trig. There's further complex numbers, there's De Moivre theory, there's hyperbolic trig, and there's also graphing of these trigonometric functions. So these things haven't been taught, but they are there on the app, because the video would have been abnormally long. So make sure that you download the app, our app, then you'll find the remaining videos. I hope that you've enjoyed, and have a very nice day. Alright, so this is the A Plus Academy app, where you find the remaining trigonometric function information. So when you come here on term 3, then you choose MA110, select trigonometry. You'll find these video lessons which have been organized in order, starting from introduction, where I've taught the basics, and proving of identities. This is where I've explained all the concepts that are very, very needed, and there are plenty of important videos. These videos are very short, don't be deceived, but they are very short that you can easily finish them within 5 days, okay? And you finish the whole trig. And the Moivre theorem has been taught. As you can see, these are complex, further complex numbers. These things comes, okay? Graphing of cardioid, graphing of these trigonometric functions, these shapes, the rows, all these things, they have been simplified. Hyperbolic trig, everything is here, okay? These are videos focusing on important things only. So the way that you download this app is that go on Play Store. So go here on Play Store, then search for A Plus Academy app. When you search for A Plus Academy app, you are going to find this app. So this is the A Plus Academy app. You can download it, or before you download, you can go through some reviews of students who have enjoyed using this app. You can come here and see reviews. You find great reviews from students who have benefited from this app. Okay, these are many reviews. In case maybe you are doubting, very soon you'll be among the students who will be testifying of how they will be helped. So download this app to access more of our video lessons. And on this app, actually, there are other topics which we have taught. Apart from trigonometry, there's calculus, even these other courses like physics, maths, everything are here. They're all A levels or non-NS work. It is here. All right, so I hope that you enjoy this video.